Good day, class. Diaz Mario, take off your hat. Okay, today we're here to talk about slope fields. But first, I have a calculus joke of the day. What do you call the first derivative of a cow? Prime rib. Anyway, today our lesson is on slope fields. I'm Grant Brown, and that over there is Diaz Mario. And this is slope fields. We use slope fields to visualize a solution curve in an initial value problem. The slope field indicates the direction of the curve from left to right. Oh, so this is an initial value problem. Can anyone tell me what is given in an initial value problem? Yes, Diaz Mario. Correct. The differential equation. What else, Diaz Mario? That's also correct. Okay, now can anyone tell me what we can use a differential equation for? That's also correct. Thank you very much, Diaz Mario. Now, what is this for? What do we use this x value for a y value? Diaz Mario again. You're on a roll. Good job, Diaz Mario. On to the next topic. Okay, now let's start the problem. So what we do is we look at this initial value problem. And what we want to do is we want to antiderive it. To antiderive, you add 1 to every single exponent of x. This x is actually x to the 1. And this 1 is actually 1 x to the 0. Because anything to the 0 power is 1. So when we add 1 to this, it becomes 2x squared. But the next step in antideriving is dividing by the new exponent. So you get 2x squared over 2. These 2's cancel, and we're left with x squared minus x because of what we did over here. But then when you antidifferentiate, you also get this c constant. Because when you derived from this equation to this equation, you could have lost a constant. So now we want to find the value of c. Luckily, as Diaz Mario pointed out, we were given this. So when y of 2, so when x equals 2, y equals 0. We plug that into the equation. So when x equals 2, y equals 0. Then we solve for c. Now we plug that back in to the original equation, getting y equals x squared minus x plus c. Plug the c back in, y equals x squared minus x minus 2. Now let's get to the namesake of our presentation. Slope fields. We're going to demonstrate this using one. Okay, now that we have put together this slope field, let's explain how we did it. For each value of x, we have a number. And if you notice, for each value of y, we don't. Now, can anybody tell me in the class why we didn't put anything in the y column? Yes, my best student today, Diaz Mario. Good job. That is absolutely correct. It is not essential at all, given that for every x value, all the y values are the same. Now, the way that we get this m is plugging each x into the differential equation. So you plug negative 5 in, 2 times negative 5 is negative 10, minus 1, negative 11. Do this for all those, and now we have all the slopes. Plug that slope in for each and every single one of these points, and we have our graph. Now, yes, it isn't drawn quite to scale. Diaz Mario and I made this today while you weren't looking at the speed of sound. And so it is not exactly drawn to scale. We rushed. So what you have to do is you have to take this, plug them all in, make a slope field. But that doesn't give you much other than the differential equation, and we were already given that from the start. So what we really want is we really want this red line, which is the graph of the solution. The way that we find this is the process that we showed you before, in which we used that and that to find this solution. Given this solution, that is drawn, and if you see, for each of these points, the slope matches pretty closely to the graph itself. And this is why slope fields are essential. They help you make sure that you got your graph right, because if you didn't, you can grievously make an error and do worse on the AP test. Now, we've gone over slope fields, we've gone over plugging it in and finding the equation, and now the security guys are getting kind of mad at me for lecturing in the middle of the quad, so I'm going to come inside now.